if you've noticed lately when you watch those TV shows, they don't go into the intro first now. They like start right off with the action and then they introduce everything later. So I'm going to do that too. And I'm going to start with a story. So imagine, if you will, you work in the SOC. If PagerDuty starts telling you got to go pay attention to this client of ours, and you start to look at this traffic and you understand that it's abnormal. You see that it's on an endpoint that's not very often used, and then you get a phone call. And the client says, well, we have an inventory API that we call to make sure that we give you accurate information about what's in the store. So if you want to come buy something at the store, there'll be accurate information there. And somebody is pinging this API constantly. And I said, well, we'll dig into it. So we looked at it, and I said, they're looking for 2 SKUs. So there's 2 items in your store that they really care about and 2 stores that they really care about, and they're just banging away on this API. Now, this is a third-party API, so they pay for every one of these transactions. So in essence, they're stealing from them. And we're trying to figure out what the SKUs are, and I look, and it was something called a hair dryer. I'm not sure if you guys are familiar with this idea, but apparently some people get out of the shower and their hair's not dry yet. And mine just automatically dries. So I don't really get hair dryers, but apparently Dyson makes one. They're $600. They sell them with a curling iron. I'm not sure what that does. And it is a combination of $800. So this team of smash and grab robbers are banging on an inventory API to see, did the truck stop and reload the shelves in this store yet, so we can run in and steal things. Aren't APIs amazing? And one thing that I've found out is that the people that attack APIs are extremely creative. And this is one example of the creativity that I'm going to talk about today, and how simply counting things will help you out. My name's Jason. Apparently I'm sarcastic, which is usually my response to stupidity, but yesterday it was just fun. I've been doing API hacking for a little while now. I think my first LASCON talk I did in like 16 or 14, I don't remember. I hacked the Chamberlain garage door API, and I opened a friend of mine's garage from my house in Ohio, and he lives in California. Last year, or 2 years ago, I was growing plants in my greenhouse, and I just planted some cucumber plants, and I was all excited to try them out. And I went outside to check on them, and something had eaten them, right? So they just sprouted, and something ate them off. And if you have ever looked at cucumber plants, they're prickly, and you wouldn't want to eat the things. I couldn't imagine what the animal was that was eating my cucumbers. So I went to Best Buy, and I bought a camera so I could put it out in my greenhouse and see what the heck was eating my cucumbers. But I'm me, so I started screwing with the APIs that camera uses, and I found out that if you type in the wrong username and it doesn't exist in the database, it tells you error, bad username. And if you try your valid username and a bad password, it says error, bad password. These errors allow what we call credential stuffing attacks to be much more efficient, but for the attacker, right? I can figure out which usernames are on the back end, and I can figure out how to find the password for each one of those usernames. So I did a responsible disclosure with them. They corrected it. It was awfully nice. I walk around the internet looking for things like GraphQL endpoints, and I'm going to talk about that in a little bit more detail. Today we're going to talk about API endpoints and what they're used for. My customers all have API endpoints that are being used: authentication, adding things to carts, right? Checking out in the retail space, but also things like logging in and getting bank account information, all of that kind of stuff. So we're going to talk about API endpoints and analytical strategies. What I'm going to be talking about today is simply counting things. It's weird, but I'm going to talk about how data science is making counting things really important to security. Finally, we're going to talk about how you can find vulnerabilities in your APIs by just simply watching what the attackers are doing. And then I'll go through I don't know, how to stop the attacks. So API endpoints can be used for all sorts of different things, right? Oftentimes they're very much like web endpoints. It's just the responses don't carry HTML with them. They don't carry anything to say how to format the page because really they're just data, right? And so as we move this data back and forth, we have to be cognizant of what is happening both from a business function perspective as well as a technological perspective on the backside of all of these API calls. What we've learned through watching attacks hit our clients is logins and searches tend to be the ones that get hit the hardest. Those tend to be your top end, right? Until you start talking about things like hype sales. If you look at, trying to go buy Taylor Swift tickets, you've got to have a bot that can really massively pound on purchase, endpoints, cart endpoints, that kind of thing. But one of the endpoints that I find the most interesting will give you HTML if you talk to it correctly, and that's GraphQL. So I'm going to give you an example of this, and it's going to come right from the internet. You can do this yourself. This is a website called fly.io. Apparently they do things. I don't know who they are. I always pick on them because they leave this environment up. This isn't the vulnerability. This is a demo environment that they have online for this purpose. But it's an interesting thing to look at. So this is their website, right? And as a web attacker, you might want to do something on this web page. But I'm an API guy. I don't care about the website. I want to see what they have as far as APIs go. So all I'm going to do is guess what they might have named their API subdomain. I got a 404 error. So everybody tell me what just happened. Anybody? DNS worked? Go ahead. Huh? Nothing there. But there's a there, right? Otherwise, I'd have got a 500 error, a DNS error. I'd have got some other burp would have gave me an error. It's running through burp. So what I know is there is no slash, right? There's no home directory that it's supposed to be presenting to me, and that's often the case. This is an API, right? So what I can then do is a little bit of inference and say, well, I wonder if they have GraphQL. They look like they're one of those modern web pages, right? And so now I'm sitting on, hang on, my flight information. I'm sitting on their GraphQL playground through their APIs. Isn't that weird? If you leave your GraphQL playgrounds on, this is what I'm going to see when I come along looking for it. And GraphQL is amazing. If you don't work with it today, maybe you'll work with it later. But if you can get on the playground, you get the entire database schema. There's all of the documentation available to you for this endpoint, right? So what I'm trying to get at here is there are dangerous things that live in your API environment, potentially, and I can just simply count the times people are trying to get to them to figure a lot of things out about the behavior of people in my environment. So one of the things that you have to do is realize attackers are going to go find your endpoints. And I started this off by saying they're creative, right? So think about it and be creative. Go reverse proxy your mobile apps. And if it's real simple and easy to do, there's your first finding. Go get the certs pinned, right? Start hiding things inside of here. And then start looking at things like APKs. If you have an Android app, I can go download it. APK is like a big YAML file. It's like a zip file. And I can just grep it and pull all of the paths out that I want. So I'd be able to see any attack path that there might be inside of your application, as well as things like content APIs, things like web endpoints. Are they the same? Are you reusing your API endpoints off of your website, or do you have new ones? There's two different attack points then, right, if you have new ones. I also look for things like documentation. Anybody here using OpenAPI? Yeah. It's funny when a hacker's on stage, people half raise their hands, because they want to participate, but they don't want to be attacked. I'm a nice guy. It's okay. So if you look at the Swagger endpoint or the Open API endpoint, depending on which way you call it and what you have, oftentimes they're public, right? And I preached for a long time, go build Open API or Swagger files because you can feed your security tools this information. And everybody that went off and did it didn't also then listen to my much quieter point about not making it public. And now I have to be louder about that. Don't make it public. It's a bad idea to make it public. And I just read the Australian DSD's recommendations for API security, and they said have Swagger files and make them public. And I thought, you almost had it. It was close. All right. So cataloging your endpoints or understanding what endpoints are being touched can help you see all kinds of different things. So what endpoints that you have in your environment, the normal endpoints are probably going to be obvious, right? You're going to have a password reset. Maybe you're going to have a login function. You're going to have all these different things in there. So PagerDuty starts going off again. SOC analyst calls me. He goes, we're seeing a bunch of weird traffic, and we don't understand what it is. And we're mitigating the traffic because we see it as automated, so we're throwing it away. But they're asking why it's happening. And so I go looking at this endpoint, and I see this verify account endpoint that's getting hit. And I realize that if you send in a username, which is an email address, it will tell you which rewards program that email address is registered in, unless it doesn't exist in the database, and then it gives you this big ugly error. So what had happened was an attacker decided that they wanted to take over all of the accounts at this retailer, and so they just started iterating through email addresses, and we hit it at about 5 million. We finally just shut them down. We were throwing their traffic away, and they weren't getting any responses back, but then eventually they started repivoting and everything, and we just shut them off. But if you have a good catalog of your endpoints, you have an understanding of what should be touched, and an understanding that that's weird, right? That's extremely weird behavior to all of a sudden just be hitting that endpoint. It's something the app should be doing, but it's not anything a user should do. And so just simply counting the number of times it got hit told us a lot about it. Now, I went to the organization and I said, well, they're hitting it here. They found it on your APK file. So what is it? And they went, 5 years ago, we bought a company and we needed to incorporate their rewards program with our rewards program. And so we put this call in just to make the points thing work. And I said, do you still have that? I mean, does it still exist that way? Oh no, we compressed all that a long time ago. Dead endpoint, right? Doesn't need to be there, take it out. But think about the functions that you have in your APIs, right? So you've got a search function that is probably going to have a bunch of endpoints or a bunch of east-west traffic, microservice that happens on the backside of it. Authentication, maybe going off to third parties or something like that. Grabbing that account info is something in the database, right? Building carts, checking for gift cards, all of that kind of stuff happens on a business function, and oftentimes the attackers are going to align to functions. So if you think about a credential stuffing attack, you don't see that on the search function, you see that on the authentication function. We had a customer come to us and say, we're seeing a bunch of direct requests to our gift card endpoint. The attacker had figured out what the sequence of numbers were to make a gift card inside of their environment. And so then he'd just send the numbers in and he'd get back the value, the amount that was on that gift card. And he sucked $250,000 out. Yeah, a lot of fun. So you're going to have to do analytics. You have to have a good understanding of how the app works, but then you have to have a good understanding of where the analytics are going to be applied. And I promise you by the end of this, you'll see how counting things makes stuff easy. So what are the things that you have to look at in order to understand a user is doing something weird? Well, Things like headers, oftentimes attackers, they don't copy and paste, right? They just make things as they need. And oftentimes the flow can be very different. So you can have headers, but you can also do things like canary headers, where you add a header if they've done this before. That way you can track them through it, right? Cart creation and cart update. If anybody here has to deal with hype sales, God love you, right? Hype sales are crazy, but what the bots have started to do now is they'll come the day before a hype sale, right? So if I'm interested in whatever sneaker, it's usually sneakers. If I'm interested in whatever sneaker I want to buy, it's not going to be available on the website. I'm not going to be able to add it to my cart. But adding an item to your cart creates a cart, and that's a step. And they want to do the least number of steps. So what they do is they add a pair of kids' socks to their cart, and then tomorrow when the SKU goes live, they're going to do an update cart, swapping out the socks for the thing that they want, and hit checkout. That's how the bots work, right? That's how they beat you every time. I've said this on the news several times. You got to be faster than them, and they're fast, right? So it makes it a lot harder. Looking at things like user agents, I'm going to let you in on a little industry secret here. The guys that write bots, they don't go back and update for the latest Chrome version until they start getting blocked on the Chrome version, right? And so oftentimes you'll see very old versions of things banging on you. And just simply counting the old user agents is going to be a pretty good data point. Where did the thing come from? That request that just came from an IP address, and that IP address probably maps to a place. What we're finding is we can find proxy networks like this, right? All of a sudden you're getting hit from a colo facility in Colombia, and you're a small, hardware store in Canada. It makes sense, right? You just look at the origin country and you can start to smash some of this out, but not just the origin country. Where did it come from in that country? Is it a residential network, right? Is it a compromised set-top box in Thailand, which is usually what it is, right? It's compromised set-top boxes wherever. Or you're looking at something like a taken over server, a bad WordPress implementation or something in a really terrible place, right? That has kind of lax laws on things like this. So you have to figure out what your analytical strategy is going to be. You'll notice I haven't gotten to the technical stuff yet. This is all just simply, we got a catalog, we got to know what's there, right? Because this isn't simple. You've got to layer these things together, but eventually you're going to come up with this analytical strategy that lets you understand things in a much better way. You understand transactional intent. What is this person doing, right? As the traffic flows. So a lot of this aligns to business goals. And so this example that I'm going to go through here, we'll have to look at sort of what you need in order to make all this work, right? So we're going to need login analytics. What I'm about to show you is a credential stuffing attack and what it looked like to one of my clients. So we do things like top-end numbers, right? So what's the most used endpoint? What's the most used login endpoint? What's the most used username, right? Being able to extrapolate those kind of analytics allow you to understand things like, well, no one asks for that ever. So isn't that weird? But things like user agents and IP address, we got to instrument in the right places in order to find those paths. So here's an example of what you might see maybe on a login endpoint. So what you're going to want to do is look at usernames. Did that username come from 6 different IP addresses? That's probably credential stuffing, right? So that analytical idea and the ability to count allows for you to start setting up machine learning, right? Machine learning to say those two things are weird. Passwords. A lot of people don't like to collect passwords, but it's an option, right? And if you were to just hash the password, or if you were to do something interesting so that you could do comparisons, it makes it really easy to say, well, why did that user try to log in 800 times, right? Credential stuffing attack, it's easy to point out. Are you using hashes? You should be. Or maybe JOTs, which are pretty much hashes. Looking at things like the IP address, the user agents, any tracking headers that you have, now you can see what we're going to start to pivot this data off of, right? For instance, if you're looking at a retail e-commerce platform, you've got cart creation also, right? The user's got to be able to do things, add stuff to your cart, update it, etc. So there's a bunch of pivots that you can develop for that. That allows for you to sort of really get to the point that you're setting yourself up to start to really count what happens on every transaction written across billions, right? And it depends if you don't have billions. So this is a quick service restaurant that does a lot of online orders for a place in the world. If you look at this green that's up here, each one of those peaks is dinner time. It's a week of data. It's pretty nice to work on this particular client because it's like the most baseline client I've ever had, right? I can tell, because they're a quick service restaurant, when things like the Super Bowl happen, you see big spikes like that. But what happens if someone comes along and decides they want to log into every one of the accounts that they have on their platform to figure out what the usernames and passwords are? Well, you can see how much traffic is generated each day, and in requests per second, they usually run about 300,000 requests per second at dinner time. And that went to 1.1 million. So when I talked about analytical strategies, one of the things I didn't talk about was just simply baselining traffic, right? Understanding that right now, we normally don't have this high of a traffic flow is a signal, is something that adds into the analytics. When this case happened, PagerDuty went off, SOC guy logged in and said, oh wow, that's a lot. But we were mitigating it. We were just throwing this traffic away, it was obvious. But then you can see how there's a double spike. So we mitigated it, and he had to go retype, he had to go VI that, or maybe used Emacs, right? And had to go correct the script so that it would run better, because something wasn't working, and so then they came back. But that didn't work either, so they left, right? But look at the amount of traffic that's happening. It's more than they process in a week, all happening in just a few minutes. This is the kind of stuff that when you're doing analytics, it jumps off the page so much that you just point right at it and go, there's your problem, right? You can easily see that the amount of traffic flowing went way through the roof. So how do we use data science, sort of in order to make these kinds of decisions in real time while you're under attack load or under hype sale load or whatever that is? Well, I didn't have a good way to articulate this, and so I thought everyone else's input onto this would be good, so I went to ChatGPT, because that's where everyone else's input is stored. And you can just ask it. Isn't that what it's for? So, anomaly detection. How can you find anomalous traffic? Well, you saw it, right? It should be pretty obvious that an anomaly is occurring if you are instrumented correctly and you're watching this traffic flow like this. Anomaly detection becomes sort of the thing that you're doing, and it leads to the rest of this stuff, predictive analysis and behavioral analysis. And you start to see patterns emerge very quickly. You don't have to watch the traffic for a really long time in order for the ML models to say, oh, I get it. This is what normal traffic looks like. But you can also do a bunch of other things with this. You can do analytical strategies in almost a SOAR environment, right? And your alerts and notifications can be processed in this way. And it's something that we do as a company because when you throw away 5 million requests, no one knows, so except the attacker. So you have to be able to kind of bring that forward. So we use it to tell people, here's what happened. Pattern recognition, computers are really good at that, right? And so as you step through these things, you have a good understanding of, well, this actually isn't a terrible thing that's out there. Data science is going to be the wave of the future. I mean, it really is going to be how we change the game. I've talked to a lot of people that are just getting interested in cybersecurity, and they're just coming into universities now, and they ask me what they should be looking at, and everyone's going to say AI, right? I say data science because I see how much benefit it has in any environment, right? So if you're looking at things like anomaly detection or behavioral analysis, let's just focus on user agents just for 1 sec. So Firefox, Chrome, Edge, Safari, Taxi, whatever it is that you're running, gets changed every now and then. So this is where things get weird, because data science helps understand, oh, a new version came out. It understands that the good flows are now going to look like this, right? And I'm talking about web endpoints here and user agents for web endpoints. Mobile apps don't tend to have user agents, but even if they do and they change, it's very easy to see it. It's very easy to see that the traffic is still good, and there's nothing that I need to do, even though this thing just showed up as a brand new thing. Because when you apply data science correctly, it looks for the good as well as the bad. It understands the normal and sees the differences. And the differences are really how we're catching all this stuff and making it work. We also see things like vulnerabilities. We can do vulnerability analysis through this. So if you look at things like data conformance, anybody here have to comply to a compliance standard? I think I was pro-compliance at speed debates, and that's the way you want to do that. But if you have a compliance standard, what are you doing in your APIs, right? Are you looking at all the traffic and saying, oh, hey, GDPR says I can't have this certain whatever in there, and here it is. You need to be able to look at things in order to see that, and monitoring is actually going to show you this, so long as you do things like open API specs and stuff like that. You have to be able to pull that from somewhere. What objects do you allow in this response, right? What data should be there? I've seen non-conforming APIs operate in such a way that they'll do a request to a backend through a GraphQL request, and we'll insert a batching request, and we'll just suck the whole database out, right? And it'll come out at once. Should I have more than one user object in here? Should I have more than one address line in a single request? Having an understanding of what's going back and forth is important. Canary URLs, I've seen canary URLs buried in like the headers and stuff like that say things like, you understand code, would you like to work for us? They usually don't have a job, posted. They wrote that years ago, right? You know how code works. So canary URLs are great in exactly the same way. If you saw Jim Manico talk this morning, he was saying, whitelist the things that you have in a drop-down box. If anybody does anything that's not in that whitelist, they're bad, right? Canary URLs sort of work the same way. If you're touching an endpoint that shouldn't be there, you're probably bad. Does anyone know what XML RPC.php is? It's WordPress.
It's wonderful.
It's wonderful.
It's a great tool.
Yeah. It allows API calls to it. You just post a JSON object to it. And you can turn any WordPress server in the world into a proxy. You can...
Thing I just deny, like access to from external users.
Right. You should. You should deny that. However, no one does that. Almost everybody, so WordPress by default installs that all on, right? You can see everything, you can do everything. If you've installed like one of their forum modules, you can make posts, delete posts, there's all this kind of crazy stuff that you can do through it. And so attackers look for it, right? Now, oftentimes these are scanners. This is somebody in Pakistan or India that has read bug crowd forums and decided to spin up a scanner and start scanning the internet because they can get $40 or whatever from you. But it happens all the time. I like to use this as a way to figure out who the scanners are. We fingerprint them, and then you understand the behavior of the scanner and you just sort of ignore it. But that's one really good example of that. WordPress also has a page called WP-admin. That's the login page. You can go change that page. You can put it on a different URL. I suggest anyone who runs a WordPress site do that. But I can start trying the default admin credentials and stuff if I can figure them out. And then there's other things that you can monitor, like token age. I'm just going to say this once because I'm really opinionated about it. Computers do repetitive tasks really well. So have them log in. Don't store a token for months, right? Because what is going to end up happening is I'm going to get it. Or someone like me is going to get it. Or someone that's got even worse ideas in their mind is going to get it. And then all of a sudden that token is very useful. And I see this a lot, tokens that they just persist in code and stuff like that. And if I see a token of a certain age, I can take action on it. And in fact, this is one of the techniques that we use for bots. They'll create the cart the day before, and then we'll time their token out and make them log in again. Really aggravates them, because then they have to come back and type stuff. So if you're using analytics, you can do things like identify that this transaction is bad. And now you have to take action on it. And that action can come in all manner of ways. For instance, I have quite a few banks that I work with, and actually my bank, whenever they do a loan program, they run the loan program through us. And if we see bad IP address, weird behavior, any kind of strange thing that goes on, we bingo marker the traffic, it drops into their fraud system, and a human goes and reviews it. Right? We're using automation to call a human to shut down the automation. I realize that's the state, right? That's the state of ML and AI today. But there's other things where we just throw stuff away. So there's a concept, IP blocking, right? I see that's a bad IP address, I'm going to block it. But that requires a bunch of understanding. And one of the things it requires an understanding of for how long are you going to block this IP address. Because if you block it forever, it's going to rotate back into a good pool again. And somebody that's legitimate is going to try to use it, and you're going to throw them away way before you should. So you have to time it out, and you have to constantly refresh this thing. It's basically the world's fastest game of high-speed whack-a-mole, right? If you're trying to do this just based on an IP address. So what if you were doing it a little more, I don't know, progressively? So here's what blocking would look like if we wanted more things. If the username appears to be in more than 4 IP addresses, it uses more than 8 different passwords, if it appears in more than 2 different browsers at a time when the traffic on the login endpoint is 10 requests per second, then we'll block it. That's a lot different than just saying that IP address is bad. That's saying behavioral analysis tells me this is bad and I want to get rid of this piece of traffic. It's an ATO attempt, right? It's a credential stuffing attack. It's something that you're going to have to develop on a flow-by-flow basis so that you have an understanding of what's happening on each thing. You have to look at the traffic. You have to go through all of this. So the very first step in all of this is finding your APIs. And you need to find them. You need to know where they are. I don't know how many times and in how many conferences, how many people have said you can't secure what you don't know you have, or some permutation of that. But the reality of it is you need to go find these things And the funny thing about this is Jim Manico put up the OWASP top 10 for web and what it did over time, right? From 2003 up to 2021. In API security, we're back at about '09. That's where we live right now. And in 2009, I spent most of my time telling people you need to go find your web apps. And now I'm telling everybody you need to go find your APIs. We've sort of lost control of them and we don't know where they are. We got to wrangle them up, figure out what's happening. What I love about this is it's very easy to do. It's usually subdomains that contain the API endpoints, and then you can infer a lot of stuff about the endpoints. There's almost always a login, V1 login maybe, right? But I can read it out of the mobile app, so I can figure it out pretty quick. But you need to know that they're there. Then you have to log all the traffic, right? And in order to do that, you have to have a pretty robust system that does it, and it needs to be pretty big. It depends on how much traffic you get. That quick service restaurant example that I showed, they don't have massive amounts of traffic that they store. They only store 2 weeks worth of traffic. But to do the analytics on it, you have to be instrumented. So once you have a place to put all this stuff, you need to be able to look at it now and then. So you have to be able to instrument it so that you can count things, right? This browser, this endpoint, whatever those things might be. That's kind of the first pieces. So then where do you put it all? Well, in order to get this data, it's going to have to be post-TLS, right? You need to have decrypted the flow so that you can look into the JSON objects to figure out what's inside of there. Otherwise, you can't count the usernames on a login flow. If you're most concerned with account takeover attacks, then you're going to look at your login flows. But if that's not what you're most concerned with, if it's your carts or whatever else, then maybe you'll look at that. And then how do you figure out you have a new flow? The developers turned on a new thing is something I often hear. Do you guys do that without telling anybody? Do you think it's funny? I think it is. It keeps the security team on their toes, I can promise you that. So how do you identify new flows automatically, right? Are you monitoring for X, Y, or Z on every single flow? And what happens when flow N shows up? You have to be able to do all of this automatically. It has to happen automatically. So you need to be able to instrument yourself for analytics. So I gave you some first steps. You got to be able to do this, you got to be able to do that, you got to be able to count. What I would suggest to you is if you're trying to do this, right, is your very first thing is, can you tell me right now how many requests per second are going through your system? If you can do that, you're well on your way to having this work, right? If you can say, I know right now I'm at 10 requests per second, then you understand that 20 is too high for right now, right? Those comparative analytics all of a sudden become really important and easy to do once you have all of this stuff instrumented so that you can do, sort of basic things like that. All right, so there's a little bit of an eye chart, but this is what it looks like when it's working. So I can see all my paths and various things. Each one of these would open, obviously. Clearly, there's something going on with Akamai up there. But what I want you to do is look at this and see the numbers, right? The numbers that are in the parentheses are the counts on that flow. If I look at the bottom, I see /Jira and /libs. These are, my eye draws to these right away, and they both have 4. And then I start to look at other things like API docs and API dash docs, and that has 4. Blue Lens has 4. Somebody's running a scanner on me. And they've made 4 requests to each one of these. Do you see it? It just leaps off there, right? This is like looking in a weblog that had a web server that got attacked. You can just scroll it as fast as you can, and you'll see the attack go by, right? It's just this easy. So I say that sort of facetiously, and if you went to the speed debates, I'm sarcastic. It's not easy. Right? Getting to this point is a lot of work. But once you get there, it's so worth it. You can identify someone scanning you on the second packet, right? You can identify that somebody is trying to do a account takeover attack just simply through analysis of the usernames that are flowing in, right? And you can work with your partners in the business and say, hey, did you know this account always logs in 6 times? Maybe there's something up with this app that they're using or the way it works, right? I've identified massive problems in app code because I'll see the endpoint start to light up with the same username and the same password pinging away, right? And what's happening is the app is not connecting correctly, but it's still sending the JSON objects in, right? And so, hey, you got an app misbehaving. You're able to see all kinds of stuff if you can just simply count, right? Now, I was going to have this be a Sesame Street talk, and the count was going to play a pivotal role, but then they did this Game of Thrones thing, and I don't think Game of Thrones and Sesame Street works quite as well together. But the count is right, you know? So we've got four, Jira. Count things, right? If you can count the things that are out there, you're going to be able to identify when the count is off, right? If you haven't watched that movie about the blackjack team from Harvard or whatever, knowing the count is important, and you should know the count at all times. That way you can pull one over on Vegas. But if you want to get one over on your attackers, you need to be able to count things. My favorite thing to set up is deceptive response, right? So in that story that we talked about where they were looking for the hairdryer, we set up a deceptive response. We told them there were 10. It was a little bit of a fib. But when they ran up to the police that were in the back of the store, they thought it was a different thing, right? They thought maybe they were being arrested for stealing. But simply, they stopped. And my client reports $60,000 worth of hair dryers, which is like 7 of those hair dryers. It's crazy. If you count things, you then know things. So if you are able to get counts on your flows and understand what's happening in those flows, you can start to understand what the behavior is of the things that are coming at you. And that becomes kind of the center of all of this. Because you can then feed the business ideas. You can tell the business what's happening in the application. On, I don't even know what day of the week it is. Thursday, Shannon was talking about understanding your customers and the customer journey and understanding where the sad face was in the customer journey versus the happy face. But this is the kind of stuff that you can feed back to the business and say, boy, it sure looks like the app is hard to use here. Or maybe part of the registration process is broken. Something like that might be something that would be useful for you to feed back to the business. So once you count things and you know things, you can start to do analytics. You take your counted items. Is this 5 million requests a problem? Is it something I need to pay attention to? What happens if it comes in low and slow? What happens if it's coming in 2 or 3 requests a day? Well, if it's fingerprinted, it won't matter, right? If you understand that, you understand what it's looking like, it doesn't matter how slow or fast it comes. But you can take action based on those kinds of things, right? And if you start to see new endpoints pop up, you might end up with an attack against those endpoints. And so being able to do analytics tells you, hey, this endpoint just suddenly became my top end endpoint and I'm at 80 requests per second. Maybe there's something here. Maybe there's something going on. Your SOC can take a little bit of action on it. So I'm gonna stop there because I'm out of stories. I have more stories. But what I wanted to do is be able to give time for questions and answers, because this is a conceptual talk, right? This is difficult and something that doesn't really line up to specific technologies that may be in your environment. So I want to try to give you the opportunity to ask me questions about what attackers do or what your environment needs or anything like that. So I'm going to give you guys a second to get your thoughts together, and then you have to ask me questions or you can't leave. And Kate's going to bring the mic out. How many of you are from out of town? No? All right. Who's got questions?
What did you specifically mean about keeping 2 weeks of traffic?
All of everything that you've counted, everything that's come in, 2 weeks of traffic. Copy,
Like
paste.
full packet capture of 2 weeks? So
Yes.
how does that work for a site that's got tens of millions of users?
So I have a customer that pushes 1.8 today billion transactions a month. So you have to have massive buckets. It's mostly metadata that you're storing, so it compresses easy. And the system that you build has to be able to just manage huge volumes of data. So what most people do is pipeline it into an S3 bucket and just keep pushing the data in and sour the data at the end. So at the end of the 2 weeks, it falls off.
Now I see why you said counting's hard.
Counting is hard. Anybody else?
Do you constrain that bucket? Because couldn't you have a huge bill for
Yes.
Amazon?
Yes, you can. Yeah.
Okay,
It's,
where was the question?
it's worse than Splunk.
You first. Oh, you were first. You don't even want to ask the question. Okay.
All right, so I've been doing a lot of work with like DDoS protection lately. We see a lot of that coming in either through, DDoS as a smokescreen for credential stuffing, low and slow. Have you used any of the newer technologies like JA3 to help identify the attackers?
So our analytical engine is mostly ML based. So we are doing Bayesian analytics. When you plug us in, you have to mark things, right? So we don't have anything like that running in the stack right now.
Gotcha.
What do you think the impact of the browser manufacturers getting more serious about privacy, especially masking IP address, user agent, et cetera?
Yeah, so we're already seeing it. They already turned it on. We see the IP addresses coming. If you look at the origin country or the facility names that come in with them, they all say Google proxy if they're coming from Google. And so it's not terrible to see that, but give them 2 or 3 minutes and people will start figuring out how to use that proxy, right? And then it's going to be a little bit of a bigger mess. So you won't be able to use IP reputation anymore because they may be bouncing it off a set-top box in Vietnam, right?
Any other questions?
So how do you triangulate the information to detect the false positive or false negative?
So the question was around false positives and false negatives. How are we tracking that? I didn't quite catch that part of the question. How are we tracking?
How you triangulate?
Oh, how do I triangulate false positives and false negatives? So one of the really nice things about being able to layer behavior is anytime somebody says, nope, that packet was wrong, you can layer more behavior in that gets those corner cases out of the way. You have to run this thing, right? Like all of this kind of stuff takes somebody managing it. And to your point, you're going to throw away the odd packet or not throw away the odd packet. And you have to have a strategy for that. So if we miss, we usually get notified in some way of that and we go and tweak things. And that's how you have to do it.
Anybody else? Well, thank you, Jason.
Appreciate it. Thanks, guys.